everyone. Welcome to the Carolina Weather Group. We're happy to have you on this Wednesday evening. We're going to be talking with Dr. Phil Klotzbach, meteorologist and professor out at Colorado State University, as well as Mr. Carl Schreck, who works for NC State University. You've also probably heard him associated with NOAA up in the Asheville office. So, Carl, a fellow North Carolinian on the show tonight, and we're going to be talking about some research that they've put together, and they are trying to get a little momentum behind of this theory of classifying hurricanes, not by the traditional way of wind speed, but more of surface pressure. And that is something that we've seen over the past couple of years with, you guys know, living here in the Carolinas, we've had our fair share of tropical weather. So as always, we appreciate you following along. And if you have any comments throughout the show, feel free to drop them in the perspective outlets that you're watching on tonight. So, Phil, we've had you on the show several times. We're happy to have you back. Carl, this is the first time for you, so I'll start with you first. Kind of give us the background of your weather history, and then Phil, I'll turn it back to you since and let you kind of give our audience a little bit of background behind you too. So, Carl, I'll let you go first.
Yeah, thanks, and thanks for having me on the show tonight. So I grew up right down there in Raleigh, North Carolina, and one of my pivotal moments was in high school when Hurricane Fran made landfall in Wilmington, followed I-40 right up to Raleigh, and just the power of that storm and all the damage that it caused and the power outages and missing school for 2 weeks, which seems like nothing now, but back then that was a big deal. So decided to go on to grad school, and to this day, my parents don't understand why I went from North Carolina up to Albany, New York to study tropical weather. But Albany is actually kind of one of the hot spots for tropical meteorology. And I did my PhD, master's and PhD in tropical meteorology up there, mainly large scale things, equatorial waves and the Madden-Julian oscillation on subseasonal scales. And then managed to find my way back here to North Carolina, where I got a postdoc out here in beautiful Asheville, working for NC State University, but at the National Climate Data Center at that time, NCDC. It's since been renamed the National Centers for Environmental Information. Yeah, we're kind of like the research arm of NCEI, doing some of the more fun researchy stuff.
And Phil, for those who may have not caught you on a program that you've been on with us before, you study hurricanes, but out in Colorado, so kind of tie all this together and let us know a little bit about you.
Yeah, so I grew up in Massachusetts, right on the coast in Plymouth, and so when I was 5 years old, Hurricane Gloria came into Connecticut, but even though it was about 150 miles away from where I grew up, it still had pretty significant impacts there, and that was kind of, I've always been kind of really fascinated by the weather, but that's really what got me focused more on hurricanes. And then I did my undergraduate at Bridgewater State in Massachusetts in geography, and then I'd done some research on seasonal prediction as an undergraduate, and so I applied to go to CSU, where Bill Gray was, and he accepted me, and I was very, very, very excited to go work with Bill Gray, because he's kind of a legend in the field of tropical meteorology and everything. And I went out to CSU in 2000, and I've been working at CSU ever since. So I've been doing seasonal forecasting, part of the team for 18 years now. And if you were to ask Bill Gray why forecast hurricanes in Colorado, he would say it's because the storm surge can't get you at 5,000 feet.
That is very true. That is very true. Well, Dan, I think you're going to kick off the topic, so go ahead.
We want to talk a little bit about surface pressure in relation to how hurricane damage is assessed. Currently, hurricanes are based mostly on wind speed, but it would be great if you could tell us a little bit more about how the pressure is actually related to the hurricane damage assessments, or how that comes into play at all, other than just forecasting.
Yeah, so this was some work, and some of this actually came a little bit motivated from me growing up in the Northeast U.S., where the Hurricane Center has been reanalyzing all those historical hurricanes, and all my major hurricanes from New England are gone. They're taking them away. They know they're only Category 2s by wind speed. And so, if you look at hurricanes hitting in the East Coast, especially from, say, like Georgia northward, the Carolinas, especially up in New England, Their structure is somewhat different from a canonical hurricane like the ones you normally see, like a hurricane hitting Texas or Florida. As these hurricanes move further up the coast, they tend to get somewhat elongated. They're a little less symmetric looking. Sometimes they're not particularly, you wouldn't have those on your wall behind you framed as a picture of what a hurricane looks like. But these kind of big sprawly hurricanes often have a significant amount of damage associated with them. And so basically, if you're thinking about a hurricane, and I think Sandy's probably the best example. I know Sandy was officially post-tropical when it made landfall, but up to about 2 or 3 hours before it was still classified as tropical. It was a category 1 by wind. Winds only about 65, 70 knots, but the pressure was down around 942, 943 millibars, which is an incredibly low pressure. And so the reason the winds weren't that strong was because basically you had a very low pressure in the center, but Sandy, as you know, was an enormously large storm. And so that pressure gradient, the gradient and pressure was spread out over a very large area. And so basically we find that pressure is more of an integrated metric of the storm. So your max wind gives you the strongest wind anywhere in a hurricane, whereas pressure gives you kind of the overall broader intensity of the storm, how large the storm is, because size is very important when it comes to the storm surge. If you have a larger storm, it tends to have a larger storm surge associated with it. And in our paper, we kind of talk about both Charley and Katrina, how you had Charley, which was a category 4 by wind, a tight little storm, very damaging, very devastating, but over a very small area, had very little storm surge, even though it went into one of the most storm surge prone parts of the US. Whereas Katrina, obviously we all know it did in New Orleans, but even say the levees it held in New Orleans have been 100% fine, killed several hundred people on the Mississippi coastline with a storm surge that approached 28 feet. Because even though its winds were slightly lower, it had a low pressure, 920 millibars. So we argue from our pressure classification scale that Katrina actually would have been a category 5 hurricane. And consequently, if you look at the damage from Katrina, even putting aside the New Orleans damage, certainly had the damage more you would expect with the category 5, just basically complete devastation and surge going miles inland.
And so, Carl, we're talking about categories. This is all based off of the Saffir-Simpson scale currently. Can you just give us a brief rundown? I know it's not all, not quite as complicated as perhaps the pressure categories you guys have produced, but can you just give us a rundown of the Saffir-Simpson scale?
Yeah, so the Saffir-Simpson scale was developed back in the, I think it was the 60s, based mainly on damage assessments, and it was tied very much to the wind speed. Originally, it was set for wind speed, pressure, and storm surge, but as the decades went on, they started to realize that those aren't always one-to-one. So the Hurricane Center is really narrowed in on using just the wind speed to define each level of the scale, going from 1 to 5. And it's convenient because it's an easy way to communicate to people how strong the storm is with just a single number, but it can also be misleading. And so, some of them are spaced closer together than others, and so there's a little bit of kind of statistical noise with it as well. And so that was, all part of why a lot of folks have really been starting to turn away from this really simple, just based on the maximum wind speed. Folks have been trying to come up with better and better metrics to identify different hazards like the rainfall or the storm surge that aren't really well captured by the winds. And also it's the winds at the center of the storm, or the strongest winds in the storm, and that doesn't really, give you an idea of the size of the storm. And so, one of the most popular alternatives to just using the wind speed is something called IKE, or integrated kinetic energy, that takes kind of the whole disk of the storm and kind of adds up all of the wind speeds throughout the size and really takes into account that size. But the issue there is that you need to know the full wind field, and that's very rarely possible, especially as you go back farther. So that's one of the reasons why we really like the pressure. I mean, no single number is going to give you a great estimate of how strong a storm is, but we think if you've got to use a single number, that the pressure seems to integrate a lot more things and is a lot easier to calculate than some of the alternatives.
But the nice thing with pressure is we measure it every time we fly a plane through a hurricane. We measure the pressure, and we have that number in real time. So basically the nice thing is someone who's TV meteorologist or emergency manager can see, here's the current pressure. look at the scale and know what it is exactly, as opposed to having to wait for, a model analysis for Ike. And that's the thing, is we need something we have in real time. And basically in real time, Hurricane Center has wind and pressure. And we argue also you can measure pressure a whole heck of a lot better than you can measure wind, both with aircraft and especially on the ground during a hurricane. Obviously, we all know anemometers tend to crash and burn in strong winds right when we want them.
So your research, is this at the point where we could see this becoming the new scale in the near future?
I don't know. I mean, I think, the general public, I think we do need a scale for hurricane intensity. I think you need a 1 to 5 scale. I mean, you look at whether it's a hurricane, a tornado, or even just like storms, you'll see TV stations will categorize it under 1 to 5. I think really what we find is that it gives you an overall better indication of, one, how much damage the storm is likely to cause. If you look at the historical relationship between wind and damage versus pressure and damage, pressure works better. And we've seen that. You see it also with fatalities. The storms with lower pressures have higher fatalities compared with the storms with lower. I mean, higher winds cause higher fatalities too, but the relationship is better with pressure than it is with wind. When it comes to storm surge in general, lower pressures, you're going to see higher storm surges, even with a stronger relationship than you do with wind. And one of the big things we've seen is a pushback against Saffir-Simpson in the last, say, 10 to 12 years, as with these large storms like Ike and Sandy doing a lot more damage than we would expect from the category. But if we were categorizing them by pressure, we wouldn't necessarily have that strong pushback, because they've actually worked pretty well. When you look at the pressures, they correlate really well with the damage. And obviously all we're looking at is the storm itself. We're not looking at where the storm is making landfall, because obviously if a storm makes landfall in, a major metropolitan area like Miami or Houston, it's going to do more damage than if it makes landfall in a much sparsely populated area. So just simply looking at the pressure, we can explain about 55–60% of the variability in the damage, not even knowing where the storm is going to make landfall.
So for a rapidly intensifying hurricane, would this provide any more, any better communication tools, or how would this apply to a storm perhaps like Michael that was rapidly intensifying as it approached the Florida coastline?
When it comes to rapidly intensifying storms, it should work about equally whether you're using wind or pressure. I would say typically your pressure is going to, you may see the pressure fall. The pressure often will fall just ahead of where the winds pick up. So it might give you a little bit of extra notice. I think a lot of what you find is that pressure works well for these storms. I would say that pressure is going to work a little more robustly than wind when you have an eyewall replacement cycle. Because when you have an eyewall replacement cycle, the storm grows in size, the winds come down, but the pressure will maybe go up a scooch, but it's not necessarily going to go up. You're not going to see as big a dramatic a variation in the pressure as you do the wind. And so often when these storms go through eyewall replacement cycles, it's like, oh good, the winds are coming down, but the pressure is staying the same or even going down at the same time. And so it's not, things are getting better, it's the storm's getting larger. And basically kind of the way I always figure it is that the pressure's falling, there's other things that come into play, but in general, if the pressure is falling, the storm's either the winds are picking up, the storm's getting larger, or a combination of both, all of which is bad. We saw this a bit with Hurricane Dorian last year, is it once it emerged from the Bahamas, it was kind of, it had weakened, the winds had come down and the pressure had gone up. But then we had a few hours where the winds were still coming down and the pressure was actually dropping at the same time. And so you kind of see the wording that the Hurricane Center was using, where it's like, okay, the category may have come down, but the storm is growing in size, so it's not like the risk is getting any lower. And so I think that's why we argue it's a smoother and more continuous function than is the wind overall. It's a lot less volatile. And again, I think really one of the key things is we measure it a whole heck of a lot better too.
Well, and you touched on earlier how the winds were, they're always going to be concentrated kind of in a smaller area. The strongest winds, as where the wind field itself can be a lot larger and still be very damaging. And how does, assigning a number to a hurricane, a category number, obviously when it comes to research purposes, you're going to be able to look at a lot more factors. But when it comes to emergency management and assisting funds that are associated with these storms, can either of you speak to, how putting a number to that storm might affect that system if you have a 4 versus a 2, and how many funds you would be able to get from that, and why it would be better to have a better rating system?
Yeah, so I'm not sure exactly how the numbers are used in that scenario. I know that like the Hurricane Center has been increasingly trying to kind of de-emphasize the Saffir-Simpson scale. So like if you look at the warning graphics, the cone of uncertainty, nowhere on there, you have to really dig pretty hard to find the Saffir-Simpson category. It may not actually be in there usually. They usually just give the wind speed and the pressure. They'll put, hurricane, major hurricane, which is category 3 or greater, but they don't really get beyond that because people seem to focus too much on the category, and they'll see, like Florence says it was approaching Wilmington, we've got downgraded from a category 4 to a category 2, but we all knew that the rain threat wasn't going away at all. And with pressure, the downgrade wouldn't have been as significant. So really where the Hurricane Center seems to be moving is, and I think this is similar to other parts of the Weather Service where it's really warn on hazard instead of warn on, the hurricane itself. So they're really more focused on, having this custom suite of different storm surge products and wind products going farther inland, and the rainfall and the flooding, like having each individual component warned on. And that's really, I think that's what the emergency managers probably really need, because they really care about what's going to happen in their county, not necessarily what's happening at the coastline if you're not, right there on the beach. But if you're on the nightly news, going through all those details is going to take a lot longer than you probably have. And so that's why boiling things down to just one number still is valuable. It's just a matter of trying to figure out what one number is going to be the best for it. And we think this is a better solution, but we'll see how quickly people pick up on it.
Have you guys looked at applying this to typhoons in the Pacific or any other basin?
I would love to do that, but unfortunately we don't have really independent pressure measurements from wind. So in the Western Pacific, almost all the assessments are based on satellite. So they have like basically what's known as a Dvorak scale, intensity estimation scale. And basically it and all its derivatives are based off of like satellite presentation, and then they assign a wind and a pressure based on that. So unfortunately, the Atlantic is really the only basin we have independent pressure measurements to actually be able to do this analysis. We actually do have aircraft recon that goes back from like 1950 to 1987 in the Western North Pacific. Unfortunately, I don't think, Carl, you can correct me if I'm wrong, but I don't think the pressure is archived in the best track though, unfortunately. So like the statistics at the end of the year, basically the Hurricane Center or the Joint Typhoon Warning Center in the Western North Pacific will go through and reassess the storm, maybe tweak its location slightly, or will maybe change its intensities. And so in the Atlantic, they archive the position, the wind, and the pressure. And in the Western North Pacific, they only archive the wind speeds.
So the other really interesting thing that Phil was touching on there with the West Pacific is, so the Joint Typhoon Warning Center, their best track historical data only reports the wind for most of the record. But we do have the pressure fixes from recon data. And the really ironic thing is those winds that are reported in the best track were almost never measured. Because if you think about it, right now, most of the winds that we get are primarily coming from dropsons. And, we look back in the 50s, we found a schematic of what a dropson looked like in the 1950s. It literally had a record player in it, like a turntable dropping down out of the sky. How accurate do you think that was for measuring the wind speeds? Not very. So, really what they were doing for most of the recon era in the West Pacific was they were actually measuring the central pressure and then using their best guess of a wind pressure relationship to estimate the winds from that pressure, because the only way they could really measure the winds was to look down at the ocean and see how much spray was coming off of the waves. And again, not a very accurate way to do things.
My, how the technology has changed. You guys have poured a lot of time and effort into this research. If some of our followers who are watching tonight, they want to kind of look at the research, where can they find that out? Where's the best spot?
So it's on. It was It's been accepted. It's currently in early online review or early online for publication, so you can view it. It's currently the way it was accepted, the way it's currently formatted. They'll actually put a nice new formatting on it. It was supposed to come out in April, but I still haven't seen like the final version, so I suspect it's now going to be May. We have some other stuff going on in the world, so a lot of stuff has been delayed. If you search Phil Klotzbach, Carl Schreck, and wind pressure, you'll definitely find it from that. There's not a lot of us roaming around.
Well, gentlemen, we certainly appreciated your time tonight talking about this as we get into the tropical season. I know there's a lot of conversations going on in the weather industry about the Saffir-Simpson scale and maybe adapting or changing a little bit. I think tonight you've got a little bit of an idea of what a future scale may look like as we go throughout the next few years. So, gentlemen, we certainly appreciate your time, and hopefully this tropical season will be a little bit quieter, but if not, when you hear about surface pressure, hopefully tonight's episode will kind of give you a better idea about how we're determining the damages that these hurricanes could cause. So thank you for watching the Carolina Weather Group. We hope you have a great evening, and we will see you back here next time.